as promised, last time when we talked about chemical changes, physical changes and chemical changes, I told you I would show you some things. Okay? So let's just review. In a physical change, we've changed the form or appearance of something, but we have all the same elements and compounds, all the same substances present. Okay? They may look different or seem different, but typically physical changes are phase changes, where we're going solid, liquid, gas of the same stuff, or if we're combining things or separating things, but we can pretty much detect most of the same properties of those original substances. Okay? But chemical changes are when we've formed a totally new type of matter. So we've rearranged the elements into different compounds, for instance, or have different chemical formulas that we can use to describe the substances. And we talked about some clues to look for when identifying whether something is a chemical change or a physical change. So let me bring out a couple of things here. So let's just start with some mixing of substances, because the mixing itself isn't, what determines whether or not something changed. It's what you observe, okay, from the mixing happening. Okay, so let's start right here. I've got it's water, DI water. This is sugar, sucrose. I'm going to start simple, and we're going to pour it in there. Okay, you can just see it in there. Okay, you can see it in there. It's sort of collected at the bottom. By the way, what's this kind of mixture called when you can see different parts to it? Yeah, that's a heterogeneous mixture. Okay. When I stir it, you can even watch as it happens. It shows up really nice in front of the lights there. There we go. So what's this process called? What's happening to the sugar? Say it louder. Sugar is dissolving. Yeah, there we go. Okay. So definitely looks different. Doesn't look like there's sugar in there. We need to stir it just a little bit more. Okay. But if I were to taste this, what would it taste like? It would taste like sugar. It would taste sweet. Okay. So what kind of change was this? Physical or chemical? This is a physical change, okay, in that it looks a little bit different. Instead of just being solid sugar, the sugar is spread out in between the water molecules, but all that same sugar is still there. Okay? And if I let this water evaporate, all that sugar would still be in there, left behind. Okay? So that's an easy one. Let me do a slightly different one where I'm going to mix two things together. This is, the wrong one. There we go. Calcium chloride solution. It just looks like water because, again, it's been dissolved in water. We deal with a lot of chemicals that are dissolved in water. Okay? When we're doing chemical reactions, having them already dissolved in water makes things convenient. Okay? So here's the other one. Here's some sodium carbonate. There we go. Just looks like water. All right. So, two substances dissolved in water. Let's get in front of the light here. There we go. Okay. I'm going to mix them together. There we go. Two colorless substances, mix them together. It turns sort of milky, opaque white, like that. Okay. So, what kind of a change was that? That was a chemical change. Okay. When we have this totally new color here that wasn't present really at all beforehand, that's evidence that a different substance is formed. The way this works, in this case, we've formed a product that cannot dissolve in water. So it's sort of suspended in amongst the water molecules like that. But if we leave this to sit for a while, we should be able to see that product settle out. So we'll check on that in a few minutes. Okay. What should I do next? Here we go. Let's do this one. All right, so I've got some, this is mostly water, I have one other thing in here, but mostly water. I'm going to add some sodium hydroxide to it. Okay? Again, something else dissolved in water, okay, but clear. All right. Add a little bit right here. Ready? Physical or chemical? Chemical, okay. Because definitely different color formed. Here I've got some hydrochloric acid. Sodium hydroxide is a base. Hydrochloric acid. Acids are sort of the opposite of bases, so they neutralize bases. So what happens when I pour a little of this acid in here? Swirl it out. And I can clean up after myself. So that works pretty well. What I had in here beforehand was a little bit of an acid-base indicator. It was called phenolphthalein, and it turns pink when something basic comes into contact with it. So we're going to use acid-base indicators a couple times in lab this semester to tell whether something is acidic or basic. Just because it's reversible doesn't really mean anything. We can have a chemical reaction that does one thing and then reverses back to another thing. Okay? But really what we're just looking for are those clues that a chemical reaction has occurred. Okay? So, got my flame here. This has propane in there. We're going to learn about the structure of propane later on, but it's a gas, at least when it comes out of here. So I turn it on. You can hear it. There's just propane coming out of there. But when I spark it, we have a flame. The spark has allowed we'll talk about the process that happens here. But first of all, just literally the process of the propane coming out of here and you seeing a flame right here, automatically seeing a flame is what kind of change, physical or chemical? Yeah, a flame is a combustion reaction. The propane in here is reacting with the oxygen in the air. It's giving off heat and light, and the propane is actually turned into carbon dioxide and water vapor. So we can do that. Here is, I always like showing this to you. This is magnesium. It's an element. Okay. Just a shiny little ribbon, sort of silver colored, soft. Check this out. You gotta hold that in the flame. Ready? This way. So magnesium burns with a bright white flame, and that's always fun, but the real reason I wanted to show this to you is that on the tip of my little tongs here, see it's turned white? Any idea where that came from? If it's a chemical reaction, there's usually some evidence that we've created a different substance, right? So we had that magnesium, we heated it up, that just sort of starts the reaction, but what was the magnesium actually reacting with when it was burning? The propane is just used to make the flame. What do you think? I'll give you a hint, if I did that in outer space it wouldn't work at all. Yeah, the magnesium is reacting with oxygen. This white powder that I have on the end of my tongs here is magnesium oxide. Combination of magnesium and oxygen that makes this white compound. So it's direct evidence of a new chemical compound that was formed by combination of the reactants. So that's kind of fun. I was like showing you that. One other one I'm going to show you. I'm going to turn on the camera over here because I want to show it to you close up. I'm just going to put some sugar in this ceramic dish here. There we go. All right, camera's on. Let's zoom in. There we go. Okay. Get this so you can see it really well. Okay, so sugar, sucrose, it's made up of solid little cubes, essentially, crystals. I'm going to hit the heat to it, but I'm going to do it just really quickly, just a little bit. See if I can get this to happen right. There we go. All right, so what I want to show you, let's see here, sometimes I have a laser. Does it have a laser? No. Well, let me get it right here. Okay, so I want you to look at this one right there. We've made a little sphere, like a little pearl of it, and there's some more of them over here. Okay? Don't look at these ones in the middle just yet. Look at these little pearls. There's some like that. Okay? What happened to the sugar in order for it to change shape into these little spheres? Okay? That was bigger than the original granules, but still sort of clear and sphere-shaped. What happened to the sugar? What do you think? Say it louder. Yeah. What happened, sugar has a melting point. Okay? It's a solid. So if you heat solids, they can melt. Okay? You can see it, especially maybe over in that one over there. Okay? And then it cools back again, so everything in here is a solid. Okay? But when sugar melts, and here, I'm actually going to try it again, because I don't like all these yellow ones. I want you to see this. There. All right. Going to try just a little bit of heat. There. So, there's a good one. Okay. Sugar has a melting point somewhere between, I don't know, it's like 150 C or something like that. Okay. But if you heat it up a little bit like that, it will melt, and then it'll freeze back to a solid again. But when it melts, it sort of forms droplets of liquid. Okay. So that's what we see. That's why we see those little spheres there. Okay. But if I hold the flame to it for longer, well, first of all, what kind of change was that when all I did was make these little clear spheres? Physical or chemical? If we melt sugar and it freezes again, those are physical changes. Okay? Some of these little spheres here, like those ones right there, those will taste exactly like sugar. Okay? There's a good one. See it? That'll be just like sugar in every way except for just the shape of its particles. Okay? Instead of being granulated, they're just little spheres like that. Okay? Let me hold the flame on it for just a little longer. There we go. So now what's happened, we definitely see a color change. Maybe if you're in the front couple of rows, you'll start to smell something. Smells like roasted marshmallows up here. Okay? What kind of a change is that? That is a chemical change. Sugar is sort of interesting because it has a melting point, but not much above that melting point is the temperature where it starts to decompose. And the molecules actually break apart. The dark color comes from carbon, just the carbon that was part of those sugar molecules. Okay? So we no longer have just pure sugar molecules. We have carbon, okay, other compounds like that. And we have different properties. It's no longer white or clear. They're dark colored. It smells different. It has that kind of charred smell to it that smells like roasted marshmallows. And later on in the class, we're going to talk about, at the molecular level, what the difference is between those kinds of changes. Okay? So physical changes where we sort of just melted it, but it stayed the same kind of sugar. It would taste the same. This would not taste the same. Okay? So your tasting is just a sensor for the type of chemical compounds that are present. Okay? So I think that's what I have to show you. You guys have any questions? If you were given a description of a process, do you think you could tell if it was a chemical change or a physical change, just based on clues? Yeah, I think you could. All right. So, all right. Oh, and then we talked about physical and chemical properties. These are just the things you can use to describe a substance. A physical property just describes the substance itself, but a chemical property describes how a substance behaves in a reaction. Okay? So how it might change if it combines with something, or maybe if it's unreactive. That's also a chemical property. Okay? So let's figure out if these three here are physical properties or chemical properties. Baking soda will react with vinegar, but not with water. This is one you've probably tried with kids or something, or maybe when you were a kid. But baking soda will fizz and bubble when you react it with vinegar, but just with water it'll just dissolve. Okay? But those are what kind of properties of baking soda, physical or chemical? Yep, those are chemical properties because they describe the reactions. Okay. Baking soda is a fine white powder, and when a powder is described as fine, that's not like a compliment. That's just talking about the size of the particles. So a fine powder has small particles as opposed to a coarse powder, which is larger particles. Okay? So if we describe baking soda as a fine white powder, those are physical properties or chemical properties? Physical, because it's just describing the substance itself. Okay. Hydrogen is explosive. Helium is not. An explosion is, well, here, first of all, if we just say hydrogen is explosive, although my statement there only describes hydrogen, is an explosion, is that a physical change or a chemical change? That's a chemical change. It's just one that happens very fast and usually gives off lots of rapidly expanding gas that makes a shockwave. Okay? So when I say hydrogen is explosive but helium is not, those are physical properties, right? No? Physical properties or chemical properties? Yeah, they're chemical properties because even though we're not describing exactly what they're reacting with, those are both chemical properties because they're descriptions of the chemical reactions that a substance could undergo. Okay? When hydrogen explodes, that's essentially a combustion reaction, a lot like the propane in the torch. It would react with oxygen, and it would make water as a product. Okay? But helium is not explosive. So that's why blimps today have helium inside of them. The Hindenburg was a blimp that had hydrogen inside of it, and we all know how that ended. So helium, having an unreactive gas inside of your blimp would be my recommendation if you're ever making one. Questions about those?